Okay, so this is the vectors video lesson for Calc BC. And okay, so before we get into any examples for like vector problems, I like to run you guys through some of the basics of vectors. So the first thing to know about vectors is that if they're starting right here, so if they're starting at the origin, then that means they are in the standard position. Now, if you look at the tip of this vector, which is where this arrow is, you can actually see that it's given by the component form, and I'll show you this right now. Hold on. Okay, so the component form is made up of v1 and v2. So basically, this acts as like an x-coordinate or xy coordinate for vectors. So as you can see, let's say this is like 3, and the y is also 3. That means the vector's component form would be 3, 3. Okay, so now a basic formula you guys might want to know cold about vectors is the magnitude. So the magnitude is the length of the vector. And it's given by this equation right here, where the magnitude is equal to the square root of v1 squared plus v2 squared. And in this case, where it's 3, 3, it's just 3 squared plus 3 squared equals square root of 9 plus 9 equals square root 18. And you can usually just leave this in decimal form, or you can simplify the ratio, but I'm not going to do that right here. So now that we have covered the really basic parts of vectors that you would probably need to know, just like when you take the AP test, let's look at this example on how to graph a vector and find its magnitude. So in this problem, it's asking us to graph the vector of 1, negative 3. So all we need to do is plot the x-coordinate over by 1, which I'll do right now. It would be right here. We don't need to plot this, but just save it in your mind. And the y-coordinate is negative 3, so we go down 3. 1, 2, 3. And there you go. That is the vector. And make sure you add the arrow after right here, so like you indicate that it's a vector, not a line. Okay, so now that we're asked to find the magnitude of this equation, so we're just going to pull up the equation. And if you recall from 20 seconds ago or something like that, the equation is the square root of the first term squared and the second term, added by the second term squared. And in this case, because the vector is 1, negative 3, we can plug this in and we would get 1 squared plus negative 3 squared. We'd have 1 plus 9, which would equal square root of 10. Once again, you can leave this in decimal form, or you can just leave it as is, and they would probably take it on the AP test. Okay, I made a cut because I forgot to add a part, but we also want to find the direction. So how we do that is we just need to plug in the tan theta over the second term over the first term. So in this case, because it's 1, negative 3, the equation would be tan theta equals negative 3 over 1, which is also just tan theta equals negative 3. So what we need to do is just take the inverse of the tan, so we can isolate the theta. So we have theta equals tan inverse of negative 3. And the answer to this is, let me see, it comes out to be about negative 71.565. Remember to keep three decimal digits after. Now we're just going to quickly go over some vector operations. And instead of like lecturing over like some basic formulas for this, I'm just going to do a practice problem right away. So let's make up a problem. So let's say vector 1 is going to be 1, 2. Sure, that's fine. And then vector 2 will be say 3, 4. Just do 1, 2, 3, 4. Okay, so let's say we wanted to add v1 plus v2, or vector 1 and vector 2 here. All we would have to do is to add the first terms together and vice versa. So basically, in this case, we have 1 plus 3. You see, this is 1, this is 3, this first term. And then we add 2 and 4 to be the answer of our problem. And after solving this, you should be getting 4, 6. Now let's say we're using the exact same equation, except we're subtracting this time. It's going to be the exact same principle. So all we have to do is simply subtract the like terms again. So if we did vector 1 minus vector 2, we would have 1 minus 3 and 2 minus 4. And this comes out to be negative 2, negative 2. So that's just like the basic adding and subtracting operations for vectors. And yeah. And additionally, if you wanted to multiply, let's say vector 1 is being multiplied by like 3 or something. So we have like 3v. You usually indicate it like this. But let's say we're using v1, so we're going to have 1 and 2. Well, all you would have to do is multiply the 3 to both terms. So we would get 3, 6. Now, in this last example, we're going to do some basic position, velocity, and acceleration application problems with vectors. So if you guys aren't familiar with those three, basically the position is equivalent to like just a regular f of x function. The velocity is just a derivative of that, so f prime of x, and acceleration is the second derivative of the position or the derivative of the velocity. So we have double prime of x right here. So okay. So, let's write a problem out. So let's say a particle is moving in a elliptical path so that its position at any time t is greater than or equal to 0 and is given by 2 sine t, 3 cosine t. Okay, so let's say part A of this problem is asking us to find the velocity and acceleration vectors. So how do we find this? Okay, so all we need to do is take the derivative of the given equation twice, as this is the position. So in this case, the velocity is going to be, let's see, derivative of sine is cosine. So we have 2 cosine of t here. And then derivative of 3 cosine t is going to be negative 3 sine t. So that is the velocity. And now we're going to take the derivative once again to find the acceleration. So derivative of 2 cosine t is negative 2 sine t. And derivative of negative 3 sine t is negative 3 cosine t. So that's that part. Now, let's say there's a part B asking us to find, I don't know. Oh, the velocity and acceleration of the motion at t equals power 4. So this is pretty simple, actually. All we need to do is plug in power 4 into both these equations. So for the velocity, we would just do 2 cosine of power 4 and negative 3 sine power 4. And whatever that equals to is the velocity. Well, I guess it's v. Yep. And then for the acceleration, same principle right here. We just plug in power 4 to find the motion. So we have negative 2 sine of power 4 and negative 3 cosine of power 4. And then whatever you solve, when you solve this, and whatever you get will be the answer to this. So yeah. That's it for the lesson for vector.